calculus. And I got in the truck and I was like, okay, it's time to go. And then it was like, no, you can't see. And it's going to take 10 minutes.
Okay, does anybody have another one you need to see? Okay, let's bump it up just a notch, and the only thing that gets harder is when you have those quadratic factors with a linear numerator. We're going to end up solving bigger and bigger systems of equations to find out what the coefficients A, B, C, D, however many we have, are. When Miss Denton was my mentor the first time I taught this last year, she actually let her students use the graphing calculator and matrices to solve for the coefficients. I decided to just not give you any problems that weren't that hard, that you had to use a matrix to solve for A, B, and C. So there were some problems that were harder than what you will see on your homework or harder than what I would give you on a test, and it's because she let her students do matrices, and I didn't feel like I had time to teach solving matrices on the calculator. I just didn't feel like I had time to cover that, so it brought my level of difficulty down just a notch, but I think that's okay, in my opinion. All right, so we know how to handle quadratic factors because we did yesterday. For example, this D, I had it written on the board yesterday. I would separate that as some A over X because that's my linear factor, and then some BX plus C over the X squared plus 1, and then DX plus E over the X squared plus 1 squared. Because you have to build up. If you have linear factors to a power, you have to build up to that power. If you have quadratic factors to a power, you have to build up to that power. And the more coefficients you have, the more difficult it's going to be to find the value of those coefficients. But that's more tedious than anything, just annoying. All right, so let me see which even ones I wanted to do as an example. 16 is just interesting because it involves several of the integration tools that we know. Let's start with that one. What's the first thing you need to notice? It's the difference of two cubes. Do you see any other method that we know that we could use to integrate that without partial fraction decomposition? I probably would see. Difference of two cubes is where you get a binomial times a trinomial. Binomial is cube root, same sign, cube root. And then the trinomial factor, I'm thinking for a second, does it start out with same sign or opposite sign? Yes. Same sign. Nope.
Opposite. It's same, opposite, positive.
That's what I was thinking, but Emma was thinking opposite. It is same then opposite. Yeah. Okay. Just had to think for a second. Same sign there. Square the first term. Opposite sign. Multiply the two terms. Last sign's always positive, and then square the last term. So we have a quadratic factor, a linear factor, and an irreducible quadratic factor. a quadratic factor that can't be factored any further. So when I set up my system of equations, or set up my partial fraction decomposition, and just copy down the fraction that I'm going to be breaking apart. In terms of the coefficients A and B and however many coefficients I need, how do I write that? A over my linear factor plus what? Linear factor over my quadratic factor. Is that all I need? Yep. Unless if the quadratic factor was squared, then I'd have to have a dx plus e over the quadratic factor squared, but I don't have that. And then I need to clear out the fractions, multiply all three terms by the LCD, cancel what will cancel, write down what's left. If I multiply the left-hand side by the LCD, what will be left? Just the 6x, because the LCD is going to be both of those. If I multiply the first term on the right by the LCD, what's going to cancel? X minus 2, and what's going to be left is a times x squared plus 2x plus 4. And the second term times the LCD will leave me the bx plus c times what? X minus 2. All right, so no more fractions. Yes, ma'am. Multiplying, because what I did was, you mean this? Yes, not that. Yes, I'm adding. Thank you. Yeah. Whew, that would be horrible if that's multiplying. All right. Do you see any value of x that would cause either the a or the b term to cancel so I could solve for what's left? Yeah. So I'm going to let x be 2. And then what will the left-hand side of the equation be? 12. And the right-hand side, the second term would be 0. That was the purpose of letting x be 2. The first term would be 4 plus 8 is 12 and 4 is 16. Double check that. 4 plus 4 is 8 plus 4 is 12. I double check that. It's 12a. So a is 1. All right. Do you see anything that I could let x be so that I could cancel out the a term and just solve for b? There's nothing that'll cancel out the a term because there's no solution if you set that quadratic factor equal to 0. It only has imaginary solutions. So I need to let a be 1, and then any, many, miny, mo, pick something else for x. I'll let a be 1. What's an easy number to plug in for x? Or 0. Either one. Doesn't matter at all. I probably would let x be 0, and then what would the left-hand side of the equation be? 0, and the right-hand side, if I do two things in the first term, if I let x be 0 and I let a be 1, what will that first term become? What'd you say, Jordan? Yep. I'm going to just go ahead and put 1 in place of the a. 0 in place of the x's would leave me 1 times 4. And then the second term, if I let x be 0 the first factor will be what? C times 0 minus 2 is negative 2. Double check that. Let A be 1, let X be 0. I have 4 plus C times negative 2. Subtract 4 from both sides. And you get C equals 2. So we know A and C, we ought to be able to find B. I'm going to put 1 in place of A and 2 in place of C before I do anything else. See what equation I have. Double check that. 1 in place of A and 2 in place of C. Is that what you have? And so, eeny, meeny, miny, moe, what do you want to let X be now? Can't let it be 0 or it would kill off our B term. We could let it be 1 again. Yeah, or not again, we haven't let it be 1 so far, but we could let X be 1. Is that what you have? So B equals negative 1. No, why are you not here yet? Double check that it doesn't count. Anybody else getting B is negative 1? You see what you find the mistake? You found it. Now we know what AX or A, B, and C are. We can go back to the left-hand side of our paper and write that original integrand as A, which is 1, over X minus 2. And I'm going to go ahead and separate my integral into these different terms. 1 over X minus 2 dx plus the integral of bx plus c would be negative 1x plus 2, or same thing as 2 minus x, over the quadratic factor. negative x plus 2. Same as 2 minus x. Let's make this, let's make them frown. See, oh, this is a good reason to frown.
Also, because that second term, the derivative of the bottom is 2x plus 2.
Okay, so you're looking at how to integrate it. You don't have a problem with anything that's written down. It's just so close.
Because I could make that a 2x, but then I have a 4. And I have a 2.
Okay. What about the first integral? Let's do what we can do. Let's, can we integrate that?
Sure.
That's just what?
Natural log of the denominator.
Natural log absolute value of x minus 2. All right, what are we seeing about this guy? The derivative would be 2x plus 2. Think of all the integrating tools that we have. Yeah, I don't think that would, that's one thing.
What if we still
2 over the denominator minus x over the denominator.
But then you have like the 2 that you keep it and then you do that. I don't know what to do. Because
I have an idea, but I'm waiting on it to occur to y'all.
is there a thing you can do? I've seen it in books where if there's like a 2 and something, you should put everything for 1 plus 1.
We've done that before.
Is that what that is? Is like that work too? Could you minus x plus x?
That's legal. I don't know if it would be helpful. It's one of the tools. What? Oh. Okay, you're saying, I'm trying to understand what you're saying. Put -1 over the denominator and then x plus 2 over the denominator? Is that what you're saying?
Just split 2 into 2.
Okay. Okay.
Then x plus 1 plus 1.
Okay. I'm gonna write it down. Sometimes I can't see whether or not it will be helpful, and I just have to try. So you're saying write the 2 as 1 plus 1 minus x. Can you say it one more? Okay.
You had flipped it, I was like, wait.
Okay.
Yeah.
Yeah, I may should have left that negative x plus 2. But 1 over this guy. I guess we're splitting it into 2 integrals. Okay. Dx. And then plus 1 minus x over that. Dx. Does that add back together to give me, or is it equivalent to what's on the line above it? Yeah. Okay. I don't yet know if that's helped me, but I wanted to make sure I did what you were suggesting, and we'll see what we can do from there. Yes. That's a good question.
Because I thought, maybe part of it was assuming that the first one we add and the next one is all that with the 0 power. So I don't think that works. I'm not sure.
Yeah, I don't don't see that as being helpful yet. I had to write it down to look at it, but now that I'm looking at it, I need to look in my toolbox. What about the idea, write down what you want and then think of a legal way to get it? That's what I have to do sometimes. Just, how can I make that be what I want? I don't think this was helpful if I... This is helpful, though. Yeah, I'll write with pencils and erase it. I'll write with ink and mark it out. Here's what I want. The numerator to be 2x plus 2, right? I also think it might have been better it would be easier on my eyes if I had left that as negative x plus 2. And what I want that to become, I want that numerator somehow to be 2x plus 2 so that it's the derivative of the denominator. Now, what would I have to do to get this to be equivalent to that? Okay, well, let's just do one thing at a time then. You're saying take out a negative, and that would be negative 2x minus 2, right? No, that'd be positive 2x. Yeah, that'd be positive 2x minus 2. That's a little bit closer. Well, I haven't quite made it equivalent to the line above it, but I'm closer. Something. What did I just do? Yeah. I brought out a negative to make that x positive because I've got to get it to be 2x. I've got to get that to be positive 2x. That's so close to what I wanted was 2x plus 2. Can you think of... My forehead will be like your forehead. What? You know I can add something and subtract something.
Well, if you want a plus 2,
add 4. Would that be equivalent to the line above it? Oh. Okay. Okay. Maybe. I'm glad we're rather writing in pencil and writing in pen. If I want that to be a 2x, how am I going to get that to be a 2x?
You need a 1/2.
Yes. Now we're getting closer. That's that gives me the 2x that I want legally, and then I feel like I should have. I want plus 1. That's a plus 2. Okay, we need one more step, but is that equivalent to the line above it? Does negative 1/2 times 2x give us negative x? Yes. And does negative 1/2 times negative 4 give us positive 2? Yes. It's equivalent to the line above it, but it's not quite yet what we need. We need a 2x plus 2, not a 2x minus 4. How could we get that minus 4 to be a plus 2? Is that equivalent to the line above it? We figured out how to get it to be a 2x plus 2. Well, let's worry about that on the next one. I'm going to break this into 2 integrals, and the first one's going to be 2x plus 2 over the denominator. Because I know how to handle that. And then what's the second integral? Is that equivalent to the line above it? And notice I have all this in brackets because the negative 1/2, we took it out before we split that into 2 integrals. Is that equivalent to the line above it? Okay. One little baby step at a time. We may get one problem done today. Now that we have this in the form 1 over u with du on top of it, what's that integral? Okay. So far, so good?
We're just gonna keep splitting it until
We're gonna keep working until we all decide to become pro volleyball players. I think that I could bring the 6 out in front of the integral. I wish I could think of something else to do at the same time. What?
Like square root of 1 plus 1 minus it? Because we would just end up with the 1 over x squared plus 2x plus 1.
Okay. And
Have we done anything? I'm sure
we did formal substitution. No, for a missing x. No, we haven't done anything for a missing x. There's still one thing that y'all haven't thought of. That's the thing.
Oh, wow. Cool.
That's the thing that I was waiting on folks to think about. Okay. I'm going to just... Getting tired of writing everything I know down, but I don't know what else to do. That's right. What would it take to complete the square on the x's? Ignore the 4 for a minute. What would it take to complete the square on the x's? Yes, and I still have a bracket. What do I add to complete the square on the x's? X squared plus 2x. Yeah, half of 2 is 1. 1 squared is 1. I could add 1 and subtract 1, or I can just call it splitting the 4. I can split the 4 into x squared plus 2x plus 1 plus 3 dx.
Well, can I use a copy of this?
Of course.
I'm ready.
It's
Because our stuff from the past probably to get the rates.
Like I was trying to be neat. And it just,
Hey, you know what
Hey.
that looks like? That looks like arctan.
You're right, that is arctangent. Yeah, that's mine. Time you ready. I told you it took everything you've ever learned in your whole life.
It is, it's alright.
I love that you can find the silver lining. At least it's not in a word problem.
It's always the same.
You're right, it is. Okay. Cheryl is right. This is arctangent, 1 over u squared plus a squared. And we do have the derivative of u, the derivative of x plus 1 is just dx. So what's the formula for integrating arctangent? U over a, isn't it? Because it's probably just 1 over a. Hey, what's a here? So 1 over square root of 3 times, oh, here's where the u over a is. Arctangent of, it's absolute value, isn't it? Of u over a. Is it absolute value or just parentheses? Just parentheses. Frankly, I don't care. You can distribute the 1/2. I think the most I would do, I'm not going to put those logarithms back together unless I have to solve an equation, but I'm going to write it as this. I'm going to distribute the negative 1/2. And I'm going to say negative 1/2 times negative 6 is positive 3. And just write the coefficient of the last term as 3 over square root of 3. And, or 3 square root of 3 over 3 if you rationalize the denominator. If you don't, minus 10. Ah! How cute that is. Let me double check. Negative 1/2 times negative 6 is positive 3. 3 over square root of 3 rationalized would be 3 square root of 3 over 3. Ah, that's awesome. Be thankful for anything you can think of, be thankful for. Makes you not as bitter when you get it. But that means we can only do one example.
an hour and 20 minutes.
You know, I was thinking last night about how limited, you know, in my other classes, I try to do one of every possible thing that could happen in the homework. And that's okay up to this point in time, but now there's no way. There's no way I can do one of every possible thing that can happen in a Cal 2 problem.
You see, what you do is you do the worst problem so that everything you do in the homework seems like nothing. Or at least,
That's one of the worst.
at least a tad bit less than that.
Okay. I would really like to get 2 more done because there's 2 things you haven't seen yet. And then I'll go make a copy of, for whoever wants a copy of this. But I want to get, there's something cool and wicked on number 20.
Oh, this wasn't wicked?
No, that was just tedious. There's something. Did you remind me to? Oh, I did record. Yes, I started. Okay. X squared plus 6x plus 4 over. Can't, what? No, numerator won't factor, but the denominator will. X squared plus 4 squared. Yeah. Okay. So let's copy down that anagram and decompose it. How am I going to separate it? Not just A, because it's not a linear. AX plus B over the quadratic factor. Perfect. LCD is x squared plus 4 squared. I multiply the left-hand side by that. The denominator would cancel and just leave me x squared plus 6x plus 4. And the first term would leave me an ax plus b times another x squared plus 4. And the third term would just leave me cx plus d. And see anything I could let x be, that would cancel out all but one of the coefficients I'm looking for. I think it's something's different because there's nothing I can let x, no real number I can let x be that would make that 0. Well, yeah, I think it would only be an imaginary number that would make that 0. You're not going to guess, let me just show you. Okay. All right. Since it's not seeming to work, we could spend some more time thinking about it, but it's not going to work like the others did. So here's the cool trick du jour. I'm just, for lack of other things to try, and this is one of those things that would not have ever occurred to me if I hadn't had to look in the solutions manual once upon a time, but I'm going to pull that out and rearrange it in descending order like I have the left-hand side. Okay. AX cubed plus 4AX plus BX squared plus 4B plus CX plus D. Double check that. AX cubed 4AX BX squared 4B CX plus D. Yes, everything we've done this year, it looks like. And you loved trig substitution. Okay, let's put that right hand side in descending order. I have an ax cubed of bx squared. Hold on, I gotta sneeze. Thank you. Just to keep from having to write the whole thing again, let me say that I have two terms with x to the first in them. I can't combine them, but I could factor out an x to the first. And you're going, well, why would I have to do that? Well, you're fixing to see. 4a plus c times x. These two terms, I just factored out the x for reasons that you might not see it, and it's okay. All right, so I've taken care of that term, and that term, and that term, and that term. What's left? The 4b plus d that don't have x's. So I've got, on the left-hand side, I have an x squared, an x, and a constant. On the right-hand side, I have an x cubed, an x squared, an x to the first, and another constant I don't know. 4b plus d. Here's the bizarre thing. See what I just wrote down? If these two polynomials, they're just polynomials, right? If they equal each other, then the coefficients of the x cubed have to equal each other, the coefficients of the x squared have to equal each other, the coefficients of the x have to equal each other, and the constants have to equal each other. Just because the polynomials equal each other. Now, that's why I put a 0x cubed on here. And so when I set the coefficients of x cubed equal to each other, what does that give me? If 0x cubed equals ax cubed, then a has to be 0. It just does. Ax, or 0x cubed equals ax cubed means that a is 0. All right, what equation do I have if I set the coefficients of, or the x squared terms equal to each other? 1x squared equals bx squared. Pretty much means what? B is 1. 2 down, 2 to go. If I set the coefficients of x equal to each other, 6x equals 4a plus c x. But I know what a is. A is 0, right? So 6x equals, that would just be cx. So what's c? 3 down, 1 to go. And if I set the constants equal to each other, then 4 equals 4b plus d. But I know what b is. got the same thing I got yesterday. A is 0, B is 1, C is 6, D is 0. How about that? If one polynomial equals another polynomial, the only way that can happen is if all of their coefficients are equal. And so what do I have when I put 0 in for A, 1 in for B, 6 in for C, 0 in for D? What will that integram become? 0x plus 1 will just be 1 over x squared plus 4 plus cx plus d would be just 6x over x squared plus 4. Squared. Yes. Actually, that's not bad. What is the antiderivative of the first term? No, I'd have to have a 2x in the numerator for that to be natural log. That's arctangent again, where u is x and a is 2, so 1 over 2 arctangent u over a. And then I'm going to say plus 6 times the integral of x over x squared plus 4 squared. And maybe you didn't need that step. Maybe you could go ahead and integrate. But I thought I could integrate better if I got that 6 out of the way. We're very, very close. One more step. Can you see it? What is it? Anybody see a U substitution that we could use informally? If U is the x squared plus 4, then what's du? 2x. And so instead of taking out a 6, I could have just taken out a 3. And then I could write that integram as u to the negative 2 with du right beside it. And what's the antiderivative of u to the negative 2 if you have du right beside it? Add 1 to the exponent, it would become negative 1. Divide by the exponent, and this coefficient would become negative 3. Ugly to the negative 1 would just put ugly in the denominator. Yep. Okay. I've got to run. Pre-calculus and college algebra are both waiting on a test. Let me show you real quickly the thing we didn't get to talk about, and it's going to look real scary, but it's not. It just looks that way. Ooh, and I need to give you that before I leave. Where's... Oh, here it is. Very last line of some page in the book says, finally, partial fractions can be used with some quotients involving transcendental functions. Look at that example. It's formal substitution. If you let UB sin x, then du would be cosine x dx. You can rewrite that all in terms of u and use partial fraction decomposition with resubstitution at the end. It sounds scary. It's not as bad as it sounds. All right. I looked at my calendar, and we'll make a copy of this for anybody that wants it. But I looked at my calendar. It was the exact same. It was the calendar you had. Yesterday was supposed to be review, but I'm glad we went ahead and did 8.5 because I have 18 problems that are a review of 8.1 through 8.5. Now, make sure you know what tonight's homework is from 8.5. Right there. But in addition to that, this has the answers on it. I want you to do these 18 problems in Monday's review. I'll do anything you need from 8.5 and anything you need from this. But this uses all of the integration skills that we have. And I guess I'll email it to Sam. And Miss Emma, do you have time to click some of you? This is Calculus Test 2, College Algebra Test 3. It is, but they didn't do so great on Test 1, so they got, that's the one I gave them a chance to retake it, and only 2 people did. No, it doesn't. So it says something about your character to me.